Welcome to 2.3 Congruence. So let's go over what it means to be congruent. This basically means having the same shape and size, and we'll be using this term to describe triangles, segments, and angles. So congruent triangles are triangles that have exactly the same size and shape. Okay, so I drew two different triangles here, and we would say these two triangles are congruent to each other because you can see they have the same measures for the interior angles, 40, 60, 80, and they also have the same measures for their segments, 8, 4, and 10. Now you can see it's flipped, but if you were to transform it, which we will get into later, if you were to transform it, you can see that they will overlap with each other and they are congruent. But also looking at the measures can indicate congruency. So when we write congruent statements, one thing to keep in mind is that it's important to have the vertices correspond to each other. So what do I mean by that? Well, remember when we talked about labeling triangles, we said it didn't matter the order of the letters. As long as we had all three letters, it didn't matter how we labeled the triangle, right? We could say ABC, BCA, CBA. Now, when you are writing a congruent statement, the order of the letters sort of matter. So there are different congruent statements I can make. So let's see, triangle ABC. Remember, to indicate congruency, it would be an equal sign with a squiggly line. So let's look at vertex A, right? This has an angle of 40. So now we have to look at this other triangle and find this corresponding vertex, which would be vertex N, because it also has an angle of 40. So we would have to write N, because you see we start with A, and we have to find the corresponding vertex. Now what's next? Vertex B, it has an angle of 80, so look at the next triangle on the right and find the corresponding vertex. We see that it's vertex O because it also has an angle of 80. So O. And lastly, vertex C has an angle of 60, and if you look at the right triangle, vertex P has an angle of 60. Okay? So remember, it doesn't matter how we label our triangles, but when we write congruent statements, it matters that our vertices are corresponding to each other in our congruent statement. Okay, so I can write ABC congruent to NOP. I can even write triangle BCA is congruent to triangle, I should put a triangle here, OPN. And lastly, CBA is congruent to triangle PON. And I did that by just doing the exact same thing, by finding the corresponding vertices. So it doesn't matter which statement you would write. You could write either of these statements, and it doesn't matter how you're labeling your triangle, but what does matter is that the vertices correspond to each other, okay? So the first vertex should correspond, and the second vertices and the third vertices should correspond to each other. Now, what conclusions can you draw? Well, there are actually 6 conclusions that you can draw. So remember, when we talk about congruent triangles, they should have the same measure for the segments as well as their angles. So let's talk about their angles first. So right away, we can see that angle A is congruent to angle N. That is one conclusion we can draw. What else? We see angle B is congruent to angle O because they both have a measure of 80. Angle C is congruent to angle P. That is because they both have a measure of 60. So these are conclusions that we can draw about their angle measures. Now what can we draw? What kind of conclusion can we draw about their segment measures? Well, we see that segment AB is congruent to segment ON. Remember, I could write segment NON, segment NO. I can write segment AB, segment BA. The order of the letters does not matter. Remember, for the triangles, they would have to correspond to each other. But here it wouldn't matter because you can label the segments multiple ways. What else? We see that segment AC is congruent to segment PN because they both have a measure of 10. We could say 10 centimeters. And lastly, segment BC is congruent to segment OP because they both have a measure of 4. So we can draw 6 conclusions. And remember, congruent statements, we can write either one of these. We don't have to write all 3, but these are 3 different ways you can write congruent statements. The important thing is that the vertices correspond to each other. Okay? So let's move on to congruent transformations. This is a transformation that doesn't change the size/shape of an object. That means no matter if you move it through these 3 transformations that I have written here, the angle will stay the same and the measures of these segments will stay the same. So remember, if all the sides stay the same, they should have the same perimeter. They should also have the same area because perimeter is the sum of the edges and the area is half base times height. So basically the sides would not change and the angles would not change. So even if you move them, it shouldn't change. So what's the first type of transformation? This is a translation. This is when you move a figure from one location to the next. For example, if I just took this figure and I moved it over here, that is what we call a translation, okay? Number 2 is a rotation. This is when we turn a figure about its center, right? So here's its center, and you can imagine this whole figure is rotating. It could be rotating in either direction. So I just wrote a series of rotations here. So that's how it would look if you rotate it about its center. Notice that the angles don't change and the measures of the segments don't change. Lastly is a reflection. This is flipping an image over the line of reflection. The way I imagine this is, imagine this triangle is looking into a mirror where this dotted line would be a mirror. So this could be its mirror image. So you can reflect it about this line of reflection, or you can reflect it about this line of reflection. Now, why are these transformations important? Well, if you're given 2 different triangles and you wanted to see if they were congruent, you can do either of these transformations to line up 2 triangles on top of each other, and if they lined up perfectly on top of each other, then they are congruent. And Apex has practice problems on these. So again, these transformations, these are actions to just move an object, but it won't change the measure of the object or the size or the shape, okay? So let's look at an example. It says, we're given that triangle ABC is congruent to triangle LMN if segment AB equals 10, segment BC equals 14, and segment AC equals 9, then what is the measure of LN? Well, how do you approach this? First thing you need to do is draw it. Remember, when we write congruent statements like this, the vertices correspond. So these vertices should correspond, these vertices should correspond, and these vertices should correspond. So let's draw a triangle really quickly. Oops. And they are congruent, so they need to have the same size and shape, so I will duplicate it. So A and L, because A is in the first position, L is in the first position, and they correspond to each other. B and M, C and N. So what are we given? We're given segment AB is 10, okay? Segment BC is 14, and segment AC is 9. So what is the measure of LN, which is right here? Well, now that we drew the figure out, we can already see the measure of LN is 9. And if you didn't want to draw the figure out, you can tell just by looking at the congruent statement, right? We're looking for the measure of LN, so LN, right? So what we would do is look at the congruent statement and identify the corresponding vertices, A, C. And in the problem, we are given AC, which we see is 9. So that is another way to look at the problem without drawing the triangles. But of course, drawing is always a really good way to help you visualize what's going on. Now let's get into congruence properties. There are 3 types of properties. Reflexive, the reflexive property states that every triangle is congruent to itself. What does that mean? This means I can say triangle ABC is congruent to triangle ABC. Now, that seems repetitive, but why is this important? This is important for proofs later on. And, okay, symmetric. Symmetric property states that every congruent statement can be reversed. For example, I can write triangle BCA is congruent to triangle MNL. Remember, it doesn't matter how I label my triangle as long as the vertices correspond to each other. Now, how would I reverse this? I can reverse this by writing triangle L is congruent to triangle BCA. So all I did was reverse these two triangles. So that is the symmetric property. And lastly, the transitive property. This states that two objects congruent to a third object are congruent to each other. So what does that mean? Let's break it down. So let's say we're given triangle A is congruent to triangle C. Triangle B is congruent to triangle C, okay? So two objects, so this would state A and B, congruent to a third object. This third object is C. Must be congruent to each other. So these should be congruent to each other. So we can also conclude that triangle A is congruent to triangle B. Okay? And these properties are going to be important for proofs.